So here we go. Let's go ahead and get started. Chapter 8, Word Problems Part 2 is your heading, and as I always encourage you guys to do, I would definitely write down the date so that your notes are organized. Alright, and so here we go, continuing on. Let's jump right into this. We're going to be looking at 3 examples in this video, okay? Just to give you a little closure so you'll know how long you have to be listening to this. We are going to be looking at 3 examples. Now, the first example we will be looking at is about a topic called continuous compounding. Okay, it's about finding interest on money that's been invested, okay? Now, before I jump into this, remember we already looked at, I'm going to go ahead and put it right here. We've already looked at this formula. And this was for compounding daily, monthly, quarterly, yearly, weekly, whatever, alright? And I'm going from memory, but I'm 99.9% sure this is correct. Now this should look familiar, okay? So this is for compoundings like yearly, monthly, daily, whatever. But this is not for compounding continuously, okay? And so we've got to keep that in mind. Okay, this formula here is for compounding monthly, daily, whatever. Then there's one formula for compounding continuously, and I'll give that to you in just a second, okay? So please don't confuse these two. Now let's continue on. Here's our first problem. Now I would encourage you in your notes to simply write down page 42, example number 4. That's what I would write in your notes. And feel free to turn over there if you want to, okay? Now we're going to look at a problem here that says you invested money, $10,000 in an account that pays 6% interest. Now, first of all, they want you to find the balance, how much money you're going to have after 10 years if the interest is compounded quarterly. Now, like I just said, if it's compounded daily, monthly, weekly, quarterly, whatever, you are going to use this formula here. And we've done that before, but I'll go ahead and do it for you quickly anyways, okay? A is your balance or your ending amount. P is your principal. So $10,000. And then 1 plus, now R is your rate. Rate is 6%, so 0.06. N is the number of compoundings in a year. Now, I know. We're leaving the money in for 10 years, I know that. But N is just how many times your money is going to be compounded in a year. So in 1 year, it's being compounded quarterly. So in 1 year, your interest will be found 4 times. Now, N is 4. So up here for this N, I'm also going to put 4. And then for my time right here, T, I'm going to put 10 for 10 years. Alright, so 4 times 10. So the first thing I want to simplify is this 4 times 10. Let's just go ahead and make that a 40, okay? Easy enough. And then I want this whole mess right here to become one number. So with your calculator, you're going to type in 0.06 divided by 4, enter, plus 1, enter, and you'll get this number right here, 1.015. Alright, so let's go ahead and clear some of this out here. And let's put this number in place of it, okay? So there we go. And now it's a calculator problem, isn't it, guys? Sure it is. With your calculator, you're going to type in 10,000, then parentheses, then 1.015, then close your parentheses, then arrow, and then 40. And you should get $18,140. And 18 cents. Now let's learn a new formula. Now they want us to find the interest compounded continuously, and here's the formula. A equals P-E-R-T, a power of RT. Boy, that's a lot easier, isn't it? That's a lot easier. So here we go. A is your ending amount. P is your beginning amount, or your principal, $10,000. E, of course, is just E. It's a number. R would be 0.06, and T would be 10 for 10 years. Now, let's quickly get rid of this mess right here by taking 0.06 times 10, alright? And that's going to give us 0.6. Okay, 0.06 times 10 is 0.6. And now with your calculator, simply type in 10,000, then hit your E button, so this pops up, E arrow parentheses, then 0.6, then close your parentheses and hit enter, and you will get $18,221, $18,221.19. All right, so there we go. So guys, this is old right here. This is new. You'll need to know both of these formulas when we take the Chapter 8 test, okay? Both of those. One is for compounding continuously. This one. This one's for all other types of compoundings, okay? Alright, moving on. The next problem we're going to be looking at uses a logarithmic function and also a little science. It's pretty cool. Okay, so here we go. At 8:30, unfortunately, it's a little about a death here. At 8:30, a coroner was called to the home of a person who died during the night. They need to estimate the time of death. Okay, so they take the body's temperature twice at 9 a.m. It was this, 85.7 degrees, and at 9:30, it was 82.8. All right, degrees. The room temperature stayed constant, so I'm going to put RT for room temperature, 70 degrees. All right, find the approximate time of death. Now, for this problem, you will need to turn to page 428. There's a formula there you need to see. All right. So on page 428, the formula, they give it to you right here. I'm going to slide this up just a little bit to get some space here, okay? Just a little bit. And the formula is KT equals the natural log of T minus S over TO minus S primed. I'm not sure why they put a prime there. It really doesn't matter. Both those S's are the same. But anyways, here we go. Now, please listen carefully. Okay, students, sorry I had to pause the video there, but let me pick up where I was here. Not sure of exactly what the last thing was that I said, but this T subscript 0 right here is always the starting temperature. So we're the first temperature or the starting temperature, okay? Starting temp. Okay. This is your ending temperature. Alright. Relax, guys. I'll explain all of this in a second, okay? So this T up here is your ending temperature. Please write all this down, students, please. S, both of these S's, is your surrounding, the temperature of your surrounding. Alright, temperature of your surrounding. So we had a room temperature of 70. That's going to be my S. That's my surrounding temperature, okay? Now, I know my handwriting's not the best, but please copy all this down. This T right here is your ending temperature. This T right here is your starting temperature. And these S's are your temperature surroundings. Now, T is your time, okay? T is your time in hours. So that's important to know. Your time needs to be in hours, okay? So time in hours. Now, this is getting into some pretty good stuff here. We do a lot of this in pre-calculus. K is a constant, alright? K is a constant, and what that means is K is a number. Let me say that again. K is a constant. That means K is a number. Now listen to me carefully. K can change from situation to situation. So you have to first find K before you can then answer the question. Because this formula right here is insufficient. It is no good until we know what K is. Got it? We got to find K first. So understand that. So I've told you what all the variables stand for. Let's get after this, okay? Here we go. Now, I'm going to slide this over here. Maybe we'll delete that later. This here, this over here for now. And then we'll pull this back down. Now, okay, first of all, let's do this. We're going to have to find K, alright? So the first thing we're going to have to do to find K is realize we're going to have to go back a little bit to the previous situation. And here's what I mean by that. Before when a person's alive, their body temperature is at 98.6. So we're going to try to solve for K and T by starting off with the body being at 98.6. So for TO right here, TO, the starting 85.7. Alright? So the first time frame we're going to use minus 70. S 70. The first time frame we're going to do is from when the person quit breathing, their temperature was this, to when the men walked in the house and found the body at 85.7. Got it? So that's our first scenario. Natural log of all of this, and then KT. Now, look guys, I'm trying to save time. You're big Algebra 2 students. All of you could take a calculator and subtract these two numbers. Take a calculator, subtract these two numbers, and then whatever fraction you get, take the natural log of that fraction. If you do all of that correctly, you're going to get this. You're going to get KT equals negative 0.6. Negative 0.6. Now, listen to me guys, take that and shelf that. Just shelf it for a second over here. So now let's continue on. Let's use this formula again, okay? Now the reason we're going to use it again is for a very simple reason. How many unknowns do I have here? 2. I have 2. So you guys know if you have 2 unknowns, you have to have another equation. So now we're going to use this equation again, only now we're going to go from this time frame here, from when they found the body to 30 minutes later, it was this temperature. So now we're going to say this. Now we're going to say my starting temperature is going to be 82.8. Sorry guys, my ending temperature is 82.8. And 30 minutes earlier, my starting temperature was 85.7. Alright, now this should make sense. So our first time frame went from the time of death to when the body was found, which was 85.7. This was our starting temperature ending. Now we're going to look at the time frame from 85.7 until 30 minutes later is 82.8. Alright, so this is our ending temperature, our starting temperature, minus 70. Now once again, you guys are big Algebra 2 students. There's no reason you cannot type in, subtract these two numbers, and take the logarithm of all of this. Okay? And if you do that correctly, for T, my fault guys, for T I can put what? What can I put for T right here? 1/2, right? Because it's been 30 minutes from 9 a.m. to 9:30. It's been 30 minutes. That's half an hour. Alright? So I can put a half an hour for T. So now I have 1/2 K equals, type all this into your calculator, and you're going to get negative 0.20422. That's rounded. Now divide both sides by 1/2, and look what you have. K equals negative 0.4. Negative 0.4. Okay? It's a tough problem, I know, guys, but it's good for us, guys. It's so good for us, okay? We're going to do about 2 or 3 of these in your homework assignment for this lesson. Now that I know what K is, what can I come up here and put for K right here? Remember this idea that we shelved earlier? K times T equals negative 0.6. Well, for K, I can put negative 0.4. T equals negative 0.6. Divide both sides by negative 0.4, and you will get 1/2. So there you go. Find the approximate time of death. Okay? So 30 minutes passed. Remember our first time frame, they got there at 9 o'clock, right? Well, it looks like it took, what was your time for the body temperature to go from 98.6 down to 85.7? Well, it took 30 minutes. So that means, obviously, no, I'm sorry, you would get 1.5. 1.5. So 0.6 divided by 0.4 is 1 and 1/2. So if they got there at 9 o'clock, 1.5 hours earlier would have been 7:30. So there's the time of death. That's pretty interesting how they figure stuff like that. And notice, it's all math. It's all math, okay? So we found the time that it took for the body to go from 98.6 when it was alive to the first reading, which was 85.7. And the time that it took was 1.5. And if they got there at 9 o'clock, then go back 1.5 hours earlier, and it's 7:30 a.m. Okay? Guys, I really hope this makes sense. Back up and watch it again if you need to, okay? Alright, now, next word problem, the last example, is about using a natural base exponential function. to solve a word problem. Rest assured, this one's much easier, okay? Here we go. If you want to turn to page 437, please feel free to do that, alright? Example 6, doubling time. You have deposited $500 in an account that pays 6.75 interest, compounded continuously, okay? Now, you're like, Mr. Arrow, we just did some of these. I know, but we're not looking for the balance. We're looking for the time. How long will it take for your money to double? So let's stop, let's breathe, and think to ourselves. Step 1, I've got to write down the formula I'm going to use. How do I know it's this formula? Because it says compounded continuously. If it was any other compounding, you would use this formula here. Don't forget that, okay? But because it's compounding continuously, then we know we're going to use this formula right here. Alright, let's continue on. So, I'm depositing 500, that's my starting amount, or my principal, alright? E, my rate is 0.0675. T is what I'm looking for. How long will it take? So I'm going to put a T right here. Now what about A? Well guys, look, how long will it take for your money to double? So if I'm starting off with 1,000, then I want to end with how much? 1,000. Doesn't that make sense? How long will it take for my money to double? So if I'm starting with 500, it's going to end at 1,000. So look at what you have, guys. You have an exponential function. An exponential function, alright? Now students, if you'll think for a second, we've learned how to solve exponential functions, okay? We know how to do this. So here we go. First of all, we've been taught to find the unknown and its base and isolate it. So we've got to get rid of this 500, okay? So divide both sides by 500 and you'll get this. Remember that? Okay, now next, we're going to take the logarithm of both sides. Both sides. And the base is going to be the base of my unknown, remember? Bring down this whole side. 2. Bring down this whole side. 0.0675t. Now, log base e, logarithm base e means natural logarithm of 0.0675 t. Guys, I'm back. I'm not sure why I'm making so many mistakes today. I apologize. Just one of those days, guys. And I apologize. It's very frustrating to you students, I know that. It's very frustrating to me as a teacher also. Okay, we put log base e of both sides, so we brought this whole side down, and now we bring this whole side down. And I do apologize. So, I brought this whole side down, 2. I brought this whole side down, this. Now, we've learned that whenever a base matches a base, all of this is gone except the exponent. So on the right side, I'm left with 0.0675t, okay? And then on the, over here, log base e is natural logarithm of 2, alright? Now, to get t by itself, we'll divide both sides by this number. So I would have natural logarithm of 2 divided by 0.0675 equals, divide this side by 0.0765, and you're left with t. And that's it, guys. So, take natural logarithm of 2, enter, divided by 0.0675, enter, and you will get, let me grab my calculator very quickly here, natural logarithm 2, enter, divided by 0.0675, enter, and you will get 10.26. I'm just going to put 10.3. So it's going to take 10 3/10 of a year in order for your money to double. So guys, 10.3, 10 3/10 of a year, 10 3/10 years for you to double your money, okay? Guys, I apologize again, I'm not sure how I went brain dead over here, but one thing about a video, class, if you did back up and watch it again, you can do that. I hope this video's been a help to you guys. If you have any questions at all,